next thing that we need to discuss about fluids, these are all preliminary conceptions, so these are not the original derivations that we are doing. Let's that is rate of flow of liquid, okay, or rate of flow of fluids. So for that we need to for this particular thing we need to arrive at a particular formula, okay, or particular expression. For that, what we are considering, suppose I am considering a tube, okay, tube like this, and water is or I will not say water, but a kind of fluid is flowing through it, okay. So suppose that fluid is flowing through it in this particular direction as I have shown by this arrow, okay. And what I will consider in this particular whole tube, I will consider two sections, okay, like this. This is one section, that is A, and another section, that is B. Fine. And liquid is flowing out like this, okay. And suppose that this distance between section A and B is equal to, say, small l, fine. And this particular area of cross section, that is equal to small a, fine. And this is small l. And suppose that the time taken by a particular liquid, suppose there is a liquid molecule which has reached section A, fine, and this is section B. A liquid molecule has reached here, okay. So it will take to reach here, okay. To reach here, this liquid molecule will take time small t, all right. So and so what we can infer from this is that, suppose that the molecule is flowing from here to here, and it has taken time t, and the distance is l. So you know that distance divided by time is nothing but what? Velocity, okay. So distance is what? L, time is t, this is velocity, fine. So this is the velocity of this particular liquid molecule, okay. So each molecule, all the liquid molecules, whoever had reached this particular section A at time t equal to 0 will take time. By the time it is t, it will reach here, isn't it? That means all these molecules have a velocity of what? V. So let's consider that velocity of flow is V. And I again want to mention that this is a streamline flow, okay. We cannot apply streamline flow, I have already explained. So streamline flow, maybe I have not explained, but streamline flow, that I want to say that the liquid molecules are always having a uniform velocity, and their velocities never change with respect to time, fine. So all the molecules will be having the same velocity. So if some molecule is following this molecule, if it is having V, this molecule is also going to have V. If some other molecule is coming, this molecule is also going to travel with a velocity V. That is the meaning of streamline flow. So all the physics theory, fluid dynamics theories can be applied to only streamline flow. We cannot apply these rules to turbulent flow. So again I will tell you that streamline flow means all the molecules are moving with the same velocity, okay. So if this molecule is moving with a velocity v, this is also going to follow the velocity v, this is also going to follow the velocity v. So velocity of flow is now what? Small v, fine. So can I write L equal to v into t? Okay, so now the thing is that now if I ask you that what is the exact volume of water that has entered this tube through section A in time t, okay, I will write it. Volume of fluid that has entered the tube as shown in figure, okay, through section A in time t is equal to. Okay, what is my question? What is the volume of water that has entered, okay, volume of liquid or fluid that has entered this tube through section A in time t? So in time t, how much it can travel? This much only. That means in time t it will cover up to this. So this is the volume of water that has entered, isn't it? Now if I ask you what is the volume of this region, then what will be that? Area. is how much? A. And what is the distance? L. So volume is A into L. Okay. Now A is fine. L means what? V into T, that we have already obtained here, isn't it? So that means A, V and T. So this is the volume that has entered volume in time T. Okay. So if I ask you what is the volume per second, that will be what? AVT by T. So that is nothing but equal to what? A into V. Okay. So this is the volume of water or liquid or fluid entering this particular tube per second. Okay. So this particular thing is called a rate of flow of fluid. Okay. So that thing is called A into V. That means rate of flow of fluid through any tube is basically equal, is a multiplication or product of area of cross section of the tube by velocity of flow. Understood? Okay, so this is a very important relation, that what is the rate of flow of a fluid, that is equal to area of cross section of the tube into velocity of the flow. So this note I have already provided. So this is a very important definition, as well as this concept is required in all other derivation that we are going to do in future.